Hello everyone, I would like to explain about cerium dioxide cobalt tetroxide porous nanoseed prepared using rose petal as biotemplate for photocatalytic degradation of organic contaminants. My name is Helmi Haji and I am from Materials Engineering. This is the appearance of journal. You can find out at Science Direct. This is Q1 journal, so it must be good journal. And for introduction, the improvement in industrialization is have side effects, something like wastewater, human health problem, and usually we have solution traditional wastewater treatment like absorption, electrochemical, and precipitation. And we must use newest solution that is semiconductor nanotechnology that have good performance, non-toxic, and pollution-free materials. And why we use cobalt tetroxide? Because have some characteristic like p-type narrow band gap, visible light response, and widely used in daily life. And why we use cerium dioxide? Because it has characteristics such as n-type wide band gap, good electrical conductivity, strong oxygen storage and release capacity, and have small redox potential. Usually, this composite is used at supercapacitors, degradation, and sensor detection. And why we use natural biotemplates? Because it has different structure, low cost, and many functional group that can absorb ion through static electricity and coordination, and also have unique surface morphology and more mesoporous structure and greener future. And for experimental, we have materials preparation, uh, pre-treatment of petals, use and synthesis of cerium dioxide, cerium tetroxide, porous nanoseeds. And after pre-treatment of petals, after synthesis of cerium dioxide, cerium tetroxide, we have characterization with FTIR, XRD, ASAP, SEM, EDS, bright field TEM, uh, ultraviolet visible near infrared spectrometer, and XPS. And we also have photo degradation tests using a xenon lamp and methylene blue and tetraethylene solution as the model of pollutant. And this is the result of FTIR. You can see many peak in here. Peak of the red one is OH stretching vibration. The orange one is cobalt oxygen stretching vibration. The yellow one is cobalt oxygen stretching vibration. Then the green one is CEO stretching vibration. That reveal pick this one provide the evidence of the occurrence of cerium dioxide and cobalt tetroxide. And this one the XRD result, that from the result we can see the characteristic diffraction peaks of cobalt tetroxide and cerium dioxide were clearly observed, and the crystal phase purity was high, which can prove that this composition nanoseed was successfully synthesized by the petal template method. And this is the nitrogen absorption and desorption analysis. We can see that for biotemplate has type 4 curve, and for untemplate the black one is type 3 curve. This one has very big surface area, is almost 50, and the average pore size is small, 17.22 nanometer. And it has something like larger number of mesoporous structure that provided rose petals provide larger surface area and will be absorb more pollutant. So this reveal this is mesoporous structure. And using UV-vis diffuse surfactant spectroscopy, we can obtain that there is three band gap. Band gap 1 is 1.7 electrovolt, band gap 2 is 2.42 electrovolt, the band gap 3 is 3.50 6 electrovolt. And this is the SEM result. The reveal that this is the back and the front of the petal is composed of a large number of irregular nodular structure, like this one. And this is a reveal that the composite is successfully replicated. This one and this one. And this is the ADS mapping. The mapping shows that oxygen, cobalt, and cerium is distribute very good in the composite. And this is the TEM result that reveal the presence of cerium oxide cobalt tetroxide composite in the specimen. And this is the XPS result that reveal the presence of oxidized particle promote the transfer of electron between each other and also prove the expected element present in the sample. We can see there is a cobalt and also cerium in every single in every single sample. And this is the result shows that the cerium oxide cobalt tetroxide nanoseed prepared by the petal biotemplate have faster and better photocatalytic performance. We can see this one is for this is methylene blue degradation, have very high performance, 96 point something in 17 minutes, and this is at TC that sample with biotemplate has very high performance, 85 point something compared to the other preparation. And this is compared to the other journal, still has high efficiency, 96 point something, that prove better than the other journal. Even this TC degradation is 85, is not better than the other, but still have high performance. And for the cycle is the performance decrease gradually, but not much, maybe some 1% or 2%. So this one for TC, the cycle is not decrease very much. And this is reveal that in the structure the performance is not decreased very much, so it can be used in a long time. And for conclusion, in this work, porous cerium dioxide cobalt tetroxide nanoseed was synthesized using rose petal as the biotemplate. The characterization results show that the cerium dioxide cobalt tetroxide nanoseed successfully duplicated the morphology of petal biotemplates, and compared with the CEO2 or CO304 nanoseed, the doping of cobalt cerium oxide makes the composite material's range of response to light increase, driving the transfer of electrons. At the same time, it also has a higher specific surface area, making the nanoseeds have higher photocatalytic activity. And the results show that under the irradiation of xenon lamp, the degradation rate of MB was 96.42% in 70 minutes with the first order reaction kinetic, and that of TC was 85.35% within 30 minutes. This work reveals that CEO2CO304 nanoseed prepared using biotemplate is a promising photodegradation catalyst of organic contaminant. Thank you for your attention.